All right, think and rake from Chapter 6. Chapter 6, think and rake. Number 39, the balls have different masses and speeds. Rank the following from greatest to least. The momenta, really the magnitude of the momentum. So again, it's just mass times velocity. So A would be 9 units, B would be whatever 8.5 times 1.2 is, C is 0.8 times 12, and D is 5 times 2. And then it's just a matter of ranking them from greatest to least. Impulses to stop them, or magnitude of impulses to stop them. Again, if you're stopping them, they're all going down to a momentum of 0. And so in terms of the whatever the momentum is, the impulse is going to be the negative of that, because you're taking it from some momentum down to 0. So if you're ranking the magnitudes, then don't worry about the minus signs, just the order would be the exact same as for A. If you are taking the minus signs into account, then potentially you're just getting the reverse. So watch out. If it's on a quiz, just watch out for the wording. If it's a magnitude, rank the absolute values. If it's not the magnitude, then just ask about which way I want to consider to be positive. Number 40, and there he is again. That's Bohr, newest member to the family. Originally he was called Bear, but we always name our dogs after scientists and engineers and the like. And so that's Bohr. B-O-H-R, as in Niels Bohr. You want to say hey to the camera? Nope. He's a cat dog. All right, so number 40. Jogging Jake's running along a flat car that moves at the velocity shown. In each case, Jake's velocity is given relative to the car. Call the direction to the right positive. Rank the following from greatest to least. Now, this is unusual. This is the first time, I think, where he actually has specified, or it's one of the few times he's specified. So the magnitudes of Jake's momenta relative to the flat car. So his mass is that we assume his mass is the same in all of them, that these are all taken at some moment in time where his mass doesn't change much. And so therefore, well, to the right is positive. So A is -4 times whatever his mass. B is positive 6 times whatever his mass. C is positive 4 times whatever his mass. And D is -6 times whatever his mass is. So you can just come up with a number, but in essence, you're ranking the velocity since the mass is the same. And then Jake's momenta relative to the stationary observer on the ground. This is the adding of velocities. We did this back in chapter 3, I believe it was. And so in A, relative to the ground, he's traveling 4 meters per second to the right. B, 4 meters per second to the left. C, 10 meters per second to the right. D, 12 meters per second to the right. I'm just adding velocities. Then we multiply times his mass. But since his mass is the same in each of these, we are ranking the momenta relative. We're ranking the velocities as we rank the momenta. Now, I have a note here that the answer key implies that he should rank magnitudes. So to the right or left seems to be being positive, seems to be irrelevant, assuming that holds. 41. Marshall pushes crates starting from rest across the floor of his classroom for 3 seconds with a net force as shown. Rank them. Impulses delivered. This is the case where we're given a force and given time. And so ranking impulses is a matter of ranking the force times time. All the times are the same, and therefore the forces will be the same. The ranking of the impulses will be the same as ranking of the force. Change in momentum. Well, impulse equals change in momentum. So if we're ranking magnitudes, whether magnitudes or not, the answer to A and B would be the same. Final speeds. So they are starting from rest. And so the change in momentum is the final minus the initial momentum. The initial momentum is 0 if it starts at rest, and therefore the final momentum and the change in momentum are the same. So the answer to A, B, and D are all the same. And then, so C, you're taking that final momentum and dividing by mass, because momentum is mass times velocity, so divide by mass. And so you'll end up with, so the first one has an impulse of 300 newtons, so a change in momentum, newton seconds, change in momentum of 300 newton seconds, and divide by 30, and you get 10 meters per second. B, 75 times 3 is 225, divided by 20, 11.25 meters per second. is the final speed. In the third one, 50 newtons times 3 seconds to give you 150 newton seconds divided by 10 gives you 15 meters per second. So I think the ranking of final speeds is CBA, if I kept that straight in my head. And 42, a hungry fish is about to have lunch at the speed shown. Assume the hungry fish has a mass 5 times the mass of the small fish. Immediately after rank, basically it's a semi-violent way of doing a collision problem. I guess we're not dealing with cars colliding like you did earlier. I don't know, usually it's pretty tame in his textbook, but for some reason this chapter is just going all out. So we don't know what the masses are, so we can make up a number just so long as the hungry fish has a mass 5 times the smaller fish. So I'm going to just pretend that the big one has a mass of 5 kilograms and the small one has a mass of 1 kilogram. So the total momentum would be 5 times 4 plus 1 times 0. I'm just doing mass times velocity of the first one plus mass times velocity of the second one. So that would be total momentum of 20. Afterwards, they have a total mass of 6 kilograms, so 20 divided by 6 would give us the speed. The second one, we have 5 times 4 plus 1 times negative 1. So that gets a total of 19 kilogram meters per second divided by 6 kilograms. And so we end up with 3 and change. And the third one, we have 25 kilogram meters per second this way and 10 going this way. So that's a total of 15 kilogram meters per second. Sorry, my mistake. 5 times 5, 25 going one way, 2 times 1 going the other way. So that's a total of 23 kilogram meters per second divided by 6 kilograms because they combine into 1. And so 23 divided by 6. And I think that's going to be the big one if I've kept track of the numbers correctly. And that's it for the Chapter 6, Think and Rank.